Good morning, students. This is your teacher Neela Mehlawat. Right, everyone? And I hope you all are keeping well. And you are following all the rules, you are following the social distancing, your family, and you are all safe. Okay, dear students? So today we'll start with the next equation, that is second equation of motion. So our topic is equations of motion, and today we'll continue with the second equation of motion. Okay, dear students, so this is our lecture number 5. Right, this is our lecture number 5 and we'll deal with the second equation of motion. Now before we go further, we need to understand, we have talked about the first equation of motion. Can you tell me, dear students, what is the first equation of motion? Anji, what is the first equation? V is equal to U plus AT. Right, this is your first equation of motion. Okay, dear students, what is V? What is V, everyone? V is the final velocity. V is final velocity. And what is U? U is initial velocity. What is V? Final velocity. What is U? Initial velocity. What is A? A is your acceleration and T is time. Yes? And we have talked about the numericals. So I hope you have no problems regarding the first equation of motion. Right, everyone? So today we'll be starting with the second equation of motion. Now coming to the second equation of motion, again we'll come to the same concept, that suppose there is object which is present at position A. The object is present at position A, and after some time when we apply the force on this object, the object has moved from position A to position B. Now the object is present at position B. So it has covered distance S. S is the distance. And it has taken the time T. Okay. When it was present at the starting position, its velocity was U. Now at this position, its velocity is V. So what is the change in velocity, dear students? The change in velocity is, what is the change in velocity? Change in velocity is V minus U. Okay, dear students, it is V minus U. Clear? So we will have the same concept that we have taken in the first equation. Clear? So you will draw this diagram, right, everyone? You will draw the diagram and let's come to its derivation. How we got to derive it? So second equation is S is equal to UT plus half AT square. Okay, this is the equation that we got to derive. And we have taken that the object is present at position A and now it is present at B. The distance covered is S and time is T. U is initial velocity, V is final velocity, and the acceleration is A. So we will be using all these terms. Okay, dear students, we will be using all these terms. Clear? So this is our statement. Now let's see what is the average velocity of this object. Do you remember the average velocity? The initial velocity plus final velocity upon total time taken, right? Do you remember, everyone? Do you remember? Yes. Average velocity is equal to, average velocity is V plus U upon 2. Okay, this is wrong here. Total time is not there. Average velocity is equal to U plus V upon 2. Okay, it is U plus V upon 2. Right, everyone? Clear, everyone? It is U plus V upon 2. Okay, so average velocity is equal to U plus V upon 2. Now we know the distance travelled will be equal to, see, speed is equal to distance upon time, we know. Speed is equal to distance upon time. So what is distance equal to? Speed into time. Okay, this will be there. Distance is equal to speed into time. So distance is equal to speed into time. Okay, speed is into time. Because here the distance covered is in straight direction, so we can call it as average velocity also. So we will multiply, right? So distance is S. And average velocity, what is average velocity? U plus V upon 2 into T. Okay, dear students, u plus v upon 2 into t, right? Now we know that v is equal to u plus at. We know that v is equal to u plus at. Now instead of v, put this value. Put this value here. So s is equal to u, and instead of v, put this value, u plus at into t upon 2. Okay. Now this becomes 2u, isn't it? This becomes 2u, right? We multiplied with t, this will become 2ut. So s is equal to 2ut plus at square upon 2, right? S is equal to 2ut plus at square upon 2. Now separate the terms. So s becomes equal to 2ut upon 2 plus at square upon 2, isn't it? So 2 cancel. So we are left with s is equal to ut plus half at square. S is equal to ut plus half at square. So what is s? The distance travelled. What is s? The distance travelled. What is u? The velocity, initial velocity. What is t? Time. What is a? Acceleration. So what is our second equation of motion? S is equal to ut plus half at square. Okay, everyone? S is equal to ut plus half at square. This is called second equation of motion. This is called second equation of motion. Right, everyone? What is the first? V is equal to u plus at, and the second is S is equal to ut plus half at square. Okay? Any doubt, everyone? Okay. So let's see the various numericals based on this formula. Okay, we'll solve the numericals based on this formula. Let's see the first numerical. Let's read it. An object undergoes an acceleration of 8 meter per second square starting from rest. Find the distance travelled in 1 second. See what is given in the question. Let's circle those values. This is acceleration from rest. It is showing from rest. Time is t. Okay. So let's see what is given. We'll write it very separately. We'll write what is given to us. So A is equal to 8 meter per second square. What is A? Acceleration. See, students, always remember, never write the complete letter. Always use the mathematical words, right? So A is equal to 8 meter per second square. Now it states the object was at rest. So starting position क्या है object की? Rest पर था. So U is 0. Okay? Because the object was at rest. Rest means object जो है वो move नहीं कर रहा था starting में. So its velocity is 0. Its speed is 0. Right? Clear? And time is 1 second. Time is 1 second. Now we got to calculate the distance. Right? A is 8 meter per second square. U is 0. T is equal to 1 second. Right? Now we'll use the formula. What we have to find out? S we got to find out. We have to calculate S. Okay, we have to calculate S. Right, we got to calculate S. Is it clear, everyone? Let's see. Let's put the value. Which formula we will use? Any idea which formula we will use? Just tell me which formula. Just think of it. Just now we have talked about one formula. That is S is equal to ut plus half at square. Again, just see, A is 8 meter per second square. It is given in the question, isn't it? Then object is at rest, so U is 0. T is 1 second. And we got to calculate S. S means your distance. So S is equal to ut plus half at square. Now put your values. See, U is 0. So this whole term will become 0. 0 multiplied 1 is 0. So 0 plus half into A is 8. T is 1. Okay. Let's take it another slide. Let's go to the next slide. So S is equal to 0 plus half into 8 into 1. Okay. So S becomes equal to 8 upon 2. So cut it. So distance is 4 meters. Distance is 4 meters, right? I hope you liked it. It was very easy, isn't it? Again, let's you see the same numerical. Given acceleration is 8 meter per second square, U is 0, T is 1 second, S we have to calculate. So we will use the formula S is equal to UT square plus half AT square. S is equal to 0 plus half into 8 into 1. Okay. Now S is equal to 0, half into 8 into 1. We'll continue with this. So S is equal to 8 upon 2. This becomes 0, right? This becomes 8 by 2. So 4. So distance covered is 4 meters. How much distance is covered? 4 meters. I hope you understood. Okay, let's take another numerical. A body is accelerating at a constant rate of 10 meter per second square. See this, the unit. What is the unit? Meter per second square. So what is this value? This is accelerating, means acceleration. So A is 10 meter per second square. Second, if the body starts from rest means your U is equal to 0. How much distance it will cover in 2 seconds? So time is 2 seconds. Isn't it? It's similar to the first question. You have been given A, you have been given U, you have been given T. What is to calculate? S. Same. The question appears to be similar to the first one. जो हमने अभी भी discuss किया, same. So which formula we will use now? Now you tell me which formula we will use. S is equal to UT plus half AT square. Isn't it, students? Yes, we will use this formula. So put the values. So U is 0. So this term will become 0 plus half into 10 into 2 into 2. Isn't it? Okay, let's write it again. Let's write it again. I'll write it very small one. So S is equal to 0 plus half A. What is A? 10. Now T square. T is 2. So into 2 into 2. Okay. So 2 to cancel. So 10 multiplied with 2 is. So S is equal to 4 plus 2 into 10 into 2. Sorry. 2 into 10. Right. So S is equal to 20 meters. So what is the distance, dear students? S is equal to 20 meters. Isn't it? I hope you have enjoyed the second equation. Yes? And do you think the numericals were very easy? Will you be able to solve now? Yes, I am expecting the same answer from your side. So I'll be giving you few questions that you can solve, you can practice, so that will really build up your confidence. Okay? And they're very, very easy. Right? They're very easy. You need to follow the steps. That is, you got to write given. You got to note down what is given. Then you get to calculate what is to be calculated. And then you must remember the formula. So 3 requirements are there for solving any numerical. Read the question, write what is given. Then what we are supposed to calculate, and which formula. Just think which formula we can apply to calculate. Isn't it? Okay. So this will be your homework for today. That is, you will complete the questions that we have discussed in the video, and you will read the page number 108. Right, dear students? So I'll be waiting for your response. Please complete your homework and send your homework to me. Okay everyone, bye.